Okay. Yeah, thanks for the kind introduction. It's almost scary because I recognize a lot of names of actually people who were with me 20 years ago in Stanford. So big wave to all of you. Good to see you again after 2 years of well, more than 2 years of not so much traveling. At least we meet virtually again. Yeah, I want to talk today about yeah, fair data spaces. Yeah, what it is, what we are doing, why we are doing it, and in fact also what is happening in Europe. Because honestly, I thought I would be talking mostly to a US audience, but I recognized also some fellow European names in there in here. And also maybe some results, but also some, let's say, call to arms, or maybe justification why things I believe should still be rethought from a semantic web link data perspective, as we, I think, have discovered. So let me continue, and let me continue. Start with something boring, namely things that we all know. Yes, we all know that data is important, right? So, and we also all know that data exchange is important. Yeah, on an individual, organizational, and societal level, probably nowadays more than ever, because we face great challenges with things like climate change, and we have to pull our joint knowledge together in order to solve those issues. Now more than ever, to be able to solve the challenges that we all face. So we know that is important, and that is indeed the reason why we need data spaces. We need some support infrastructure for sharing this data, because simply putting, let's say, data on the web, as we have done it in the past with things like Sparkle Endpoint, or simply dumping, for example, linked data or RDF data or anything else on the internet, is not going to cut it. And that's exactly why we need this notion of data spaces. Data spaces is much more than a Sparkle endpoint. And that's what I want to talk about. And in particular, then also we have fair data spaces. So first of all, let's look into what are data spaces. So first, data spaces as a term was introduced by Franklin, Halevi, and Meyer in about 2005 within the data management community. And the idea was to be able throw everything in it that's been available without a particular care of format, location, or model. But nowadays, as it is being used and it has also evolved over time, it broadened to some sort of decentralized infrastructure for trustworthy data sharing and exchange in a data ecosystem based on commonly agreed principles. That is at least one of the definitions that you can find out there. But honestly, there are several definitions, and so it's much more fruitful to look into current data space projects rather than define it exactly what it means. So what data spaces are able to solve, or should support, provide support for, is to answer questions like where to find data, or who has the best quality data, or answer questions like how to use data, and in particular, how can data be provided while keeping sovereignty of it? So be in control of it. And that leads us directly to some data space design principles, which might explain what data spaces actually are and how they are perceived or envisioned in there. And when we look at data space design principles, there are some technical and infrastructure principles, and also some governance principles. So let's look into the technical and infrastructure principles. And there's the idea of data sovereignty. So exclusive self-determination of economic, data goods. That's the core idea. And why is this increasingly becoming important? So yes, we have to share data. We want to share data. We want to enable others to do something with it, but not at all costs. And in particular, and that's probably true in more in Europe than the US, but I think increasingly also in the US, there are legal requirements to protect it. It's easy to see in sensitive areas, maybe health data, that the data for sure should not be left unprotected, just being published. Personal data is something that should not be left unprotected. But even in that so-called maybe non-sensitive areas, like for example, in the cultural domain, people spend a lot of effort and time and money in curating their data set. So they want to justifiably so keep some level of control over it. Yeah, so the notion of sovereignty, in particular in Europe, with the GDPR, is of particular important, and it should not become as a surprise that some of the examples that I will talk about are about, for example, in the medical domain. Yeah, but I think they apply elsewhere as well. So then another technical infrastructure is what's called a so-called decentralized and soft infrastructure. Now, the definition of soft, I think, comes from an electrical engineer. So in the sense of it's not cables and wires, but it's in fact legal and economic agreements, standards, ways how to do things. Yeah, so that is probably true for many types of software, but to an increased level also for data spaces, and that will lead on or continue and maybe more explored when we talk further about fair data, what that is. But then there are other also governance design principles as well. So one principle would be the level playing field. It's from my perspective related to Tim Berners-Lee's principle of everybody should say everything about anything. So in other words, there should nothing to prevent people, let's say, unnecessarily to be part of it. So people should be able to share and provide their data inside a data space. Now, mind you, there's still access control part. So look at the data sovereignty part, but there should not be overly bureaucratic levels or things preventing things. And then that's maybe also a particular European perspective. There should be a public-private governance, or in other words, a sound governance by representation of all stakeholders in there. So these are the principles applied to also the German data spaces, or the European data spaces, shall we say. So there are in Europe several examples of data spaces which are happening. I don't want to go into too much detail in all of them. We go deeper into the idea of fair and what fair means for data spaces, but at least want to introduce you to some of them so that you also have an idea where to look and what to do. So one of the first data spaces approach that happened was probably the IDS, International Data Space by the Fraunhofer Society, which also to some extent acted as a blueprint for a European effort, which is called Gaia-X, initially being created by the French and the German government, but now it has about 359 members so far. In fact, international, mostly European, but also a lot of American participants and mostly companies. So it's aiming at exchanging data for industry, for industrial applications. Its development is coordinated by a non-profit Gaia-X, European Association for Data and Cloud, which is actually located in Brussels. And it has a number of different levels on which infrastructure is currently being created. All of these efforts, by the way, in particular, probably Gaia X, are to some extent, yeah, I should call them top-down approaches, in the sense of they're being planned and funded and well executed and being done. So Gaia X is probably most of the one top-down. A couple of them are in fact so somewhere in the middle, particularly the next one that I talk about, which is the NFDI, the National Research Data Management Initiative. Here, and I call it data space, to create research data management spaces for, in the end of the day, well, everything in science. Now, everything can't be covered, so we talk about 30 different consortia in a variety of different fields. And this is now where a bottom-up approach is coming, because these organizations, these research community, have to organize themselves and discover what they want to do with sharing and what to achieve with sharing this kind of data. There is a central office for the NFDI being run out of Karlsruhe. And I say hi to the members of much better than I could. But here we see some of the diverse areas that are participating and set up consortia. So, for example, in the medical domain, we have NFDI for health, we have material science with NFDI Matwerk, engineering for NFDI for Inch, there's data science in there, biodiversity, more text resources as a community, bird data plant, there's an NFDI for energy, and a lot more which are now being funded, and some of them are running for about 2 years. And a third set has just been now approved and is now coming together. So what binds, or principles that bind these data spaces together, is in fact the notion of fair data. And fair data is in fact quite interesting concept. First of all, it's an acronym, obviously, for standing for findable, accessible, interoperable, reusable. I could imagine that many people here have heard this acronym, but maybe others have not. So it's originated from a paper in Nature by Mark Wilkinson and others, called the Fair Guiding Principles for Scientific Data Management and Stewardship. And I think the success of the Fair Data acronym and its meaning has been phenomenal. And I think its greatest achievement is to make something fairly technical actually comprehensible, yeah, and package it quite well to be able to communicate it at the same time. It originated, so most of the authors are from the biosemantics community, so sort of the intersection between life sciences and semantic web, but not all of them. And I don't think that the principles by themselves should be confused with linked data and or semantic web. For sure, the notion can help. They support each other, but it's not the same. And I want to look into actually why they are not the same, and also when they are support each other, and maybe also take some inspiration about what we should change and maybe look into. But it has taken the data space world by storm, I can say. It is the basis for the common European data spaces, which are just emerging. I'm going to talk about those in much more detail, and some more detail later on. For sure, the NFDI, it had made it into political documents which set up the National Research Data Management Infrastructure. It's the basis for the European Open Science Cloud. It's the basis for some of the national data space projects which are happening in Germany, like, for example, the cultural data space, which just now got approved, and now also increasingly for Gaia-X and the international data space. So, but if you look at it, at the paper, what does fair data actually mean? So what is in it, apart from being a nice, positive, great sounding acronym? So if you look at the fair data principles, you discover three different things which they mentioned, which have a technical content. So one is persistent identifiers. The second is rich metadata. And the third one is open protocols. So hardly something that anybody can disagree with, particularly probably not people who are on this call, but it's still something which I believe should be discussed and maybe examined in some more detail. So since this is the basis for so many of the data spaces, it also made sense in order to create interoperability between the different data spaces to let them base on the FAIR principles. And one of the projects which in fact also my institute is participating in is the FAIR Data Spaces project, which aims at connecting the business side and the science side in some joint effort. There is this being the International Data Space project and Gaia-X as the EU and world counterpart, and NFDI and possibly the European Open Science Cloud or global Open Science Cloud, and creating some joint project based on the fair data principles. But it's not only business and science, but also culture, which got started, which is using the FAIR principles in here. The cultural data space is in fact a very interesting project, aiming to and actually actively pursuing culture provider in order to do not only publish data and share data, but actually provide services like, for example, music education in a joint data space. So this opens up the idea of just sharing data to also share services in a data environment, which I think is a very interesting prospect also for the others. The common European data spaces, and there are a lot of them around, were originally announced in the European Strategy for Data in February 2020, so not so long ago. And then from there on, it progressed quite rapidly. The European Council recognized the need to accelerate the creation of the common data spaces, and including ensuring access to and interoperability of data in a decision or document from 25th of March 2021. That's just 1.5 years ago. Yeah, and we talk about political entity here, which are supposed to be very slow. That is something that I really cannot confirm here. So key features of the common European data spaces are European values. Yeah, that's European rules and values. Something to be adhered to, particularly also secure and privacy preserving infrastructure. And then we are again at data sovereignty, which I mentioned, which is also the guiding principle of Gaia-X and the IDS, and a clear and practical structure for access to and use of data in a fair written small, but also in capital letters, transparent, proportionate, and non-discriminatory manner in a clear and trustworthy data governance mechanism. And in an initial start, the one that have been proposed and are actually already up and running, well, implementations are up and running, are Green Deal, mobility, industrial and manufacturing, public administration, energy, finance, health, skills, and, well, the European Open Science Cloud in there. And from a time plan perspective, which was published in February this year, we can see that most of them are already running in some initial phase and are continuing well into 2023 for practices and federated infrastructure. So we have to see how well they're coordinated. I know that there are some national counterparts, for example, in Germany, for mobility. There's a mobility data space, which still will have to be connected to a European one, given that certainly mobility is something that can be cross-border. But it's good to see that these projects are already running, in particular, since we also are in the European Union very interconnected. For example, we have one large European energy grid in here, which for sure needs information to be shared and to be used. So what I talked so far about were, as I announced previously, the large top-down projects, with LFDI meaning maybe one exception in the sense of that it also has a bottom-up project. But there are also data space projects, in particular from this community here, which are purely top-down, which are purely bottom-up, namely grassroots driven. Now, by one particular prominent member of the community, quite obviously, and by this you probably have an idea already what I talk about. Namely, one data space project which would fit into this collection very, very well is the Solid project initiated by Tim Berners-Lee himself, which also aims, interestingly enough, at data sovereignty, but more at personal data sovereignty. So it was not aiming initially at business data, also in the community, so on the Glitter chat. It turns out there are also companies who are using Solid pods for company data exchange in there. So I think it would be worthwhile for the larger projects and maybe a Solid project to also see at what can be used and reused to from each other. And well, if you look at the Solid web page, it turns out Solid is a mid-course correction for the web by its inventor, Sir Tim Berners-Lee. It realizes Tim's original vision for the web as a medium for the secure, decentralized exchange of public and private data. But it's, I think, very interesting to note that we have top-down as well as bottom-up projects. And I think they should probably meet or will meet somewhere in the middle in here. So far with tour de force through some of the data space projects. What I want to talk about at this point is some concrete work in terms of fair data and actually maybe some issues with fair data. Also some maybe comparison and relationship to semantic web linked data. And yeah, let's see what this means. And first, let's look into open protocols. And when we talk about protocols, we also have to talk about protocols for what? Of course, data exchange. But one thing that changes with data spaces is the notion of data analytics, because simply you cannot dump all your data in one central repository anymore. That's exactly what the data space should not do. Remember data sovereignty, right? So people should aim and should keep and should be in control of their data. That means also be able in control who does what and who does analyze what with their data. So hospitals, for example, in Germany, I'm sure also elsewhere, are not allowing data of their patients to leave the premises. Yeah, it would be a violation of GDPR and very difficult to circumvent. So if centralized analytics, so putting all data from, let's say, several hospitals does not work anymore, what can work instead? Yeah, and putting this together is not allowed anymore. So what we have to do instead is, so if we cannot bring the data to the analytics, what we have to do is to bring the analytics to the data. Yeah, so in other words, do some federated or institutional incremental learning approaches. And that's exactly what the fair data community has in fact also developed, and where there are now first prototypes are being available. Part of them from also my chair and my institute. So one particular concept originated from the Go Fair community, which is the personal health strain. So which is a distributed analytics infrastructure to support data management, data analysis, and medication decision making. And same with data spaces, the idea is to keep the control over data at the data owners, and in particular aim at health data, but the solutions are actually applicable also elsewhere in there. And so what are the principles in here? So there's an analogy from the real railway infrastructure. There are three basic entities in the personal health strain paradigm. So one is we have the train, which encapsulates the analysis of and the results, and it visits multiple stations. The stations, again, analog to the real railway station, acts as a data holder and provider, and trains visit each station step by step on a predefined route, and the station grants access to the data sources, but also controls what the train will in fact do. That's where the metaphor breaks down a little bit, because trains typically don't do much with stations, but in this case they do. And the tracks connect then multiple stations, like rails. The trains are self-sufficient. Their operating systems, software library dependencies. There's algorithms and query do the static, but also create machine learning, like for example, dynamic. The stations then create the confidential data, expose the data in discoverable format, and provide computational resources, and they execute analytic tasks in a secure environment. So part of this, if you look under the hood, how that works like, part of the personal health and technology stack is a containerization technology. So in our implementation example, it's Docker. Container is like a cooking box, which brings the necessary ingredients for a meal. So in the container case, it means that all the libraries and dependencies are included in the container. The container is a train. This brings some advantages such as operation system independencies, compatibility with all data sources, programming languages. You can use Python, R, or even Java for the analysis. And the only necessity is a Docker engine. It has to be installed before the execution. So in order to execute a container, the train and responsible person at the station has to execute a pull command to download the train and grant access to the data source. And the data source can be anything, so image data, omics data, or even simple CSV files. And there's a bit more to this than what I just outlined. We can also talk about certification, and we want to make sure that a downloaded train doesn't do anything evil. So that's also part of that. But the core part is what I just said. So if you want to have a look, so the prototypes and the code is available at padme-analytics.de. So Padme is a concrete now implementation of the personal health strain idea, and it looks like we can look at it from different perspectives. So the builder creator service supports the train creation workflow. The storehouse is like the Google Play Store, presents all available trains, possibly certified, so checked if they do something evil or not. The requester sends trains to the station on a predefined and user-defined route. So the station registry gives an overview on all available stations and can be used for the registration of a new one. The station software provides several interfaces and manages the trains at the corresponding stations. And the list of bullet points here shows some of the functionality, but I won't go into the detail. And then from a security perspective, so each station has its own repository for the trains. The train contents are asymmetrical and encrypted. Storehouse works as an app store. Community reviews the trains and provides feedback for the establishment of trust. Yeah? And a result inspector at each station answers then the question, what information will leave my station? Yeah? Because again, the data protection officers in German hospitals are very nervous about any kind of information leaving their particular organization. Yeah, let me skip to the registry and provide you some use cases where PADMI has been applied. At this point, there were experiments with open source data, for example, skin lesion images. Task was to train a model which classifies the skin lesions into 8 classes. And these pictures have been distributed across 3 institutions in Germany. So one being RWTH Aachen, Fraunhofer FIT, and the University of Applied Sciences in Mittweida. And the outcome was that it is possible to train a model on decentralized data, which I think by itself is already an interesting result, and achieve similar results to a centralized model, which I think is well, surprising or not, I'm not sure, but it's good news that this kind of setup actually works. Yeah, there was a second use case with PADMI on breast cancer. Similar to the first use case, the data has been distributed across 6 institutions, Aachen, Cologne, Göttingen, and a couple of others. Yeah, average onboarding time was in fact 15 minutes, so it was quite fast part. So this takes care of the, let's say, data analytics protocols part, which is something that we in a fair data space environment have to take care of. Yeah? But of course, there are other issues with fair data. And maybe now I'm coming towards, I think what from my perspective are more open issues, some research issues, and some questions which I would like to ask also maybe to the community and maybe ask for ideas, and later on also a bit of a rant from my side. So one issue with fair data is persistent identifier. So why are persistent identifiers an issue? And I know that Tim Berners-Lee himself actually said URIs should be cool, and cool URIs don't change, but the reality looks different. So a resource persistence is not quite there with conventional URIs or URLs. So we have link rot over time. Things disappear. And that in a data environment is a disaster. That shouldn't happen. Yeah. So yes, the W3C says cool URIs don't change, but unfortunately they do. And that does not work well in an environment. So that's the reason why we need something else than just being URIs. We need something different, which is more persistent. One of the reasons why DOIs are being used. And there's more. I mean, data on the web is constantly evolving. So even the notion of PIDs will need to change and adapt and maybe increase and include some of those notions. Yeah, there have over time, in fact, also been attempts to evolve the URI notion with this. So also to include versioning, for example, and domain authorities and timestamps, etc. And there are now also some attempts, some quotes here to provide this also for PIDs. But there's a bit more about PIDs. So do we actually need? What that we need to use PIDs for data spaces? So first of all, we have the identifier, and we have obviously a persistence layer. Yeah, some resolver together with a service level agreement. The service level agreement is exactly what is missing in a pure URI case. There is no service level agreement. Yeah? You cannot rely on it being there. Now, even old organizations can disappear, but a service level agreement and enough interest should take care that the URIs or the identifiers are being managed at least. So the likelihood it's been available is a lot higher than in the pure web URI case. And there are additional requirements. Of some of them I will talk about. So what are most popular PID systems these days? So one for example, is Handle, invented by Bob Kahn, one of the original internet inventors. And the digital object identifier, DOI, are one subspecies in the Handle ecosystems. Others are, for example, ePICs and a couple of more. So how does Handle look like? Well, it looks like this, at the prefix and a suffix. And the prefix basically says what is hosted on a specific server. And there is a general resolver for that is hosted by the Donor Foundation, which is located in Geneva, Switzerland. In other words, the Handle system is centralized. Yeah, okay. Not sure we want that. Yeah, do we want another centralized organization running things? But there are other requirements for PIDs as well. So there are at this point of time, a tremendous resources of identifier being available and it's being generated. Yeah, and of course I'm talking, so people, you know what I'm talking about. I'm talking about Wikidata, yeah, which is the melting pot of interoperability in the web and internet space, where lots and lots of IDs could be reused. And right now there's no way to use them with existing PID systems that we have. There is nothing that would connect them or that would provide a process how to use and reuse it. So that's a definite lack, because it's just a tremendous resource which would do so much for making data interoperable if there would be a proper support infrastructure. Another requirement which we need, which is support for public and private PIDs, and in fact switching between those two. Think of it, this is just an arbitrary example. Think of the pharmaceuticals who work on their own private protected products. Yes, they have to integrate data. The pharmacy, by the way, is using lots and lots of fair data internally and also for pre-competitive research. But for sure, they don't want to publish everything, particularly not what kind of development products they're working on, what kind of clinical trials maybe are happening, at least not be published before the time. They want to make it public then later in time when they reach a different stage in their life cycle, meaning PID systems need to be able to distinguish between something that is public and that is private. And the public part should also include and reuse ID systems, something like Wikidata, yeah, as one particular example. So there's more to it than just a handle system where everything is being public and can be seen. We know already that this doesn't work in an industrial environment. So that gives rise to some research and standardization agenda for persistent identifier systems. So we have decentralized, where there's centralized use and reuse of established ID systems, and service level agreement and metadata schema for PIDs as one additional topic. So which brings me to now almost the end of my talk, and now a little bit of a rant that I have. And maybe some people will disagree with me here. I'm happy to discuss this, but I'm going towards the the notion of rich metadata in FAIR. So what does rich metadata require? Rich metadata requires ontologies in many different domains. In many domains, it requires lots and lots of people in very specialized areas to agree. And I think agreeing ontology is hard. In particular, sometimes is impossible. And I believe that the problem is our current understanding of ontologies and the current instruments and methods that we have. And this is a rant that I have for quite a while, actually. So some of you may not have heard it for the first time, but unfortunately, I'm afraid I have to repeat it. And the first thing that I believe is wrong with the notion of ontology is sort of this picture. Yeah. So what is wrong with this picture? What do we see here? We see here some higher level entity, the gods of a particular domain, giving down to the peasants who want to share the data, all the commandments expressed as an ontology. And all that the peasants can do is adopt this ontology and use it to share data. Oh, that's what the gospel is, isn't it? So that's what we then do. So what's wrong with this picture? Well, this is about data sharing. So sharing means also connecting the data to each other. That's exactly what ontologies don't do. I can use the vocabulary, I connect it, maybe somebody else can use it, reuse it, but I sure cannot directly connect it. I cannot build these connections in real time. And the hell, why not? Why not? Why should this not be allowed? Why should this not be a possibility? Yeah, that I can directly use and reuse it and link to it and make it part in a networked environment. Why do I have to do this in this top-down fashion? Something I don't really understand up to this day. So second part is modeling is too hard. So if you ever created an ontology, I'm pretty sure, yeah, let's say in the holy language, OWL, yeah, gold standard of all ontology languages, web standard. I'm sure you had to make a decision to decide if something is a instance or is a class. And yes, in theory, this sounds simple, and I'm sure the purists and theoreticians and philosophers will always tell me exactly what is, but in reality, it depends on the application that I do. If my domain is of Discord, is for example all species, then my species are instances. If I just look into one, for example, animal, then species might be a class. In other words, it depends on the application if something is being modeled as an animal, as a class or an instance. And sorry, that's not right. It should enable iterability, not prevent it, and that's what it does. So some of the issues that I have is that the differentiation in classes and instances is difficult. There's no single way to abstract the world. So for example, I'm sure they're mostly fought by now, but we can observe the upper ontology wars, so-called discussions. The choices between instances and classes done at design time cause usability issues, so different treatment and applications. And ontologies also cement power structures. Yeah, they prevent information sharing. Seriously, I'm convinced they prevent information sharing. And sharing is only top down. Yeah? I cannot create and link my data. And I think that's plain wrong. And how did we end? There? So why do we have this class instance relationship? Why is it modeled in the way how it is? And it's just because a particular branch in history of knowledge limitation has been taken. Yeah? Originating in semantic networks in 66 by Quillian, by Minsky advanced to frames, then came KL1, then Pat Hayes, actually, of all people, chose a particular way to formalize it. So creating this class instance conundrum and actually formalizing in a particular way when there were others. And then the whole description logic thing happened. And then a couple of clueless people, me being among them, then chose the description logic formalization and put them on top of RDF. And here we are. Yeah, but there were other ways. For example, the notion of prototypes, in fact, were part of early framework systems. They fell by the wayside. And my suspicion is they were disregarded because Pat Hayes did not choose to formalize them in his 79 paper. But I may be wrong. So I asked him once, but yeah, let's see. But there are also class versus prototype-based programming languages. Yeah? In fact, you are all using prototype-based programming languages as we speak, which don't make this class instance distinction. One language, namely, who has this built in is JavaScript, something that we all use. So how could this work in a data space? Well, one company could point to an information object at a university and say, my object, my protein, for example, is maybe particular specialization of another protein being published by a university. Or maybe my protein is like another protein, or my object is like another protein with some exception, with some differentiation. So that would create a network of information, and we can develop our ontologies using this network. Yeah, to then re-engineer it and then create those ontologies that we now have to spend so much countless hours and trains and sweat to agree upon to just emerge organically inside the system. So I think that would pose another research agenda, namely look into knowledge representation constructs, data sharing in the distributed network. So obviously there are issues with respect to that as well, but something that we have managed to work with on the web, because similar issues exist for information distribution in web environment. And maybe shape expressions, tackle and checks as we have it, can serve as a basis for this kind of connection already, because they do something very similar than specifying those objects in the expression. So that is a distinct possibility. But with that, I'm convinced I'm almost running out of time. So Marco is probably already quite nervous. So I'm going to end with this, my rant and my talk. Thank you for your patience. I hope also my microphone did work all the time, and I'm still talking to somebody, because that's something that I really don't know. And
thank you very much, Stefan. Actually, that was the most interesting part, the second half, for me at least.
Okay, and I think with those fair data principles that we have, yeah, we can hopefully turn our data spaces that we have, our now distinct data spaces, on using the fair data principles into a real network.
Okay, so you have put the gauntlet down. Some pretty harsh words, especially for someone who has spent so much time in the community considering ontologies as well. But I actually would like to ask the audience to pause come up with questions now in the next 15 minutes. And just unmute yourself and ask questions. So if there are questions, let me see if I have. Yeah, please go ahead.
Okay. Oh, thank you very much, Stefan. That was really good. I appreciate that. My question is, I feel that for knowledge representation and reasoning process or paradigm, we need the ontologies now because of the semantics part of it, in the sense that how do we because for most of my own perspective, for the upper level ontologies, they work with the domain experts and they understand what a particular concept is about. So if we're working on fair principle using maybe the RDF or merge representation principle, we even start with logic principle like the description logic. But how do we give specific semantics to most of those concepts that must be represented for us to have a shared community? And I feel that that's what the ontology is all about, giving specific meanings to most of those concepts.
Before you answer, Stefan, Tayo, could you please introduce yourself before you?
Cool. Oh, I'm so sorry. I had to just jump into it because of. So my name is Tayo. Yes, I work as a knowledge engineer in a startup called Squirrel Labs, and we're into biomedical research presently. I'm based in Nigeria.
Very good.
And my research, oh yes, let me go ahead. My research interests are in ontologies, biomedical research, knowledge representation and reasoning, description logic, particularly edition D, because of its expressivity.
Very good. Now, Stefan, do you have the full question? Could you respond to that?
I'm not sure. I got the question. To be honest, Marco, can you repeat that?
I think he asks, what should he look for now? What is the alternative to do the upper, ontology level semantics? When you get rid of it, like what do you propose to instead? I mean,
yeah.
So should I repeat myself?
Yes, please.
Oh, cool. So what we're saying is that if we look at the certain Berners-Lee semantic web caked layout approach of how concepts should be represented, right? We have URLs, we have the RDF and all that formalism that can be used to represent concepts. Now, when we look at trust and logic, which is part of the ontologies, which is part of the formalism, what other way, if we want to give semantics, want to give meanings? So for syntax now, we could use RDF XML, we could use other formalism to represent the syntax. Now, but what about for the meanings? To give meanings to those concepts that we have been represented, that have been represented in the syntax, what do we do then?
Yeah. Okay. I think it's a good question. So let me rephrase that, and I did not go into that much detail. I mean, when it comes to the prototype top concepts of let's say frame systems that we have. So some notion of semantics can be drawn from that, and we have also evolved and changed some of that. So what can be done? It involves even to some extent non-monotonic reasoning. Yeah. So for example, you could clone an object. You can say my object is similar to that with those exceptions. Yeah. So that is establish a similarity between two objects. Then similar to OWL, but OWL does it in an open world sense. You can see, as Check and Shackles does, use constraints for validation. So you can say certain properties, certain values of attributes need to be within a certain range. Yeah, and in that sense, you could use objects also as some sort of ontology. So just prototype approach does not prevent that from happening. Yeah, to have central objects lying around when there is sufficient social capital there in order for people to look into exact one entity. So let's say a car manufacturer, let's say VW, for example. Yeah, they want to get the supplier to publish all the business records in a certain way so that VW can act to that. There's enough social capital in their in existing power already to get those entities, those suppliers to provide this kind of data. So for VW can publish some sort of prototype object and say, please use them in that way. They act exactly as a top-down ontology. So these things are still possible. What is not possible in there, and I give you that, is this expression classification approach that description logic supports. I was never really convinced how useful that is to the practice. I never used it, to be honest, but maybe somebody else has an idea where this is being useful. And again, that could still be something on top of that if it's useful. I just doubt that it is so useful that it has to be forced upon the rest of the data sharing community.
Okay, I think we take another question. We have 5 more minutes in the Q&A. Yaroslav, yeah.
Yeah, good evening, good afternoon. Stefan, this is a pleasure meeting you again in such a context. So thanks for the presentation, Hadi. I'm just wondering about one crucial part of your of the concepts you introduced. This is sovereignty, and very much recall one of the tricky part was, defining sovereignty and enforcing it. And at the time we were looking at the ODRL language for specifying conditions on when to share digital assets. I'm just wondering about progresses in this result, in this aspect. So specifying rules for permissions on use of digital assets of valuable private data within the spaces. So these were the different extensions to the open digital rights language, to ODRL. I think the data spaces we're looking at. I'm just wondering about the current status in this regard.
Yeah, it's a good question, but not one that I could answer. That probably has the Gaia X team, in particular Christoph Lange-Bewald, probably to answer it. I know that that there will be in Japan in February a workshop about policy language. And I think this will also be a discussion point in there. But to be honest, what exactly how the language looks like currently in Gaia X, I would know.
Thank you. So because I recall even just the implementation support for ODRL was quite limited at the time. I know these initiatives started, and just wondered about how this all the domain matured over the time. Okay, thanks so much.
But the Gaia X implementations are available in a repository on GitHub. So a simple Google search should reveal what the current status is. I couldn't provide you now a dedicated answer to that.
No, this is all fine. Okay, because I just recall this was quite tricky. For example, in order to identify what is at the end the digital artifact asset we are talking about, is this a document? So so you were referring to identifier systems, and just really to identify what is the subject we are about to specify a restriction, a policy, a usage policy upon. So this very much interacts with many of the aspects you introduced. Okay, thanks so much.
Very good. Thank you very much, Jaroslav. We have time for 1 or 2 more questions. Yeah, Greg, please go ahead.
Hi, Greg Trzeciak. I work on a SaaS solution for manufacturing industry. My question is in regards to the train analogy. I'm having a problem with this analogy, so the question that could help clarify it: where is the engine for processing? Is the engine on the train or at the station?
The engine is at the station.
Okay, so I think that the better analogy could be like a cable car. So basically something that is being pulled by the stations.
Yeah.
Okay, Yeah, that makes perfect sense. Yeah, so that was one question, and regards to the prototypes. Yes, I must say that whenever I work personally with RDF data in JavaScript, I purposefully avoid using classes and I use prototypes. It makes perfect sense for me. So
okay, thanks.
It's very intuitive, and I must say that very often I find myself really hoping that I wouldn't have to choose between, I know, a class approach or a prototype approach. So I'm really glad that I'm finding someone else that thinks in a similar manner in regards to prototypes and RDF.
I would thank you very much for that comment. If you, I would urge you write down your experiences, and that would help, because I think the community is still pretty much, well, ruled would be the wrong word, but influenced by the current notion and the current standards, and I don't think they cut it.
Yeah, I think I should write down something in terms of my own experience, but yeah, I really find it very intuitive.
Thanks a lot.
Very good. Thank you very much, Greg. So one more question. Okay. If there are no questions anymore, I would close the official session, the Q&A. And that means I will stop the recording now.